The next topic we're going to cover in our coverage of the core observable operators in RxJava is the operators that involved with transforming. And in particular, we're going to talk about the map transforming operator. And as you might expect, based on the name of this section, these operators transform the values and or the types that are emitted by an observable. And I hope you also like my Optimus Prime animation here, which demonstrates the concept of transforming. Thought that was kind of a good analogy to think about. So we'll start with a map operator. This will look very familiar to you because we have these in Java streams and parallel streams as well. And what map does is it transforms the items that are emitted by this observable, and it does something to them. It maps them. And the way it works is it applies a function synchronously to transform each item. This, again, is very, very reminiscent of Java streams map. Now, normally things will run to completion and everything will be transformed, but the map operator can terminate if the mapper function that's passed to it happens to throw an exception. It returns a transformed observable. Whatever the mapper method or mapper function does, that will be the output that it is going to emit. Now, something to remember here, this is also very similar to map in Java streams. The number of output items must match the number of input items. So map will multiply, in this case, each of the elements in the observable stream by a constant. So you can see the marble diagram up above starts out with a bunch of different values of a particular type. And after applying map, you have the same number of output elements coming out as you did for input, unless an exception occurs, of course. The other thing to notice here is that the ability of map can transform the type and or value of elements that it processes. So just to make a finer point on that, you can see here that we've transformed the types as indicated by the different shapes, and we've also potentially transformed the values, for example, multiplying them. Project Reactor has a map operator that works in exactly the same way. You can multiply each element in the flux stream by a constant. And this is also very similar to the map method in Java streams, as we've talked about before, where, as I show you here, you can uppercase each string in a stream. And if you have 3 strings coming in, you should end up with 3 streams coming back out the other side. So that's the end of the first discussion about transforming operators. There will be a bunch of other transforming operators we'll cover later, the most important of which is flatMap. And just something to remember, I'll cover this later when we get to it. The flatMap operator in RxJava and Project Reactor, for that matter, is much more powerful and much more common than the flatMap operator in Java streams. So it does not have all the limitations. They do not have the limitations in RxJava and Project Reactor with flatMap that they do in Java streams, where, for example, in Java streams, you don't want to use flatMap in a parallel stream. With the RxJava and the Project Reactor implementations, in contrast, flatMap is very commonly used even in concurrent and parallel use cases.